All right, 12.1 deals with the fundamental counting principle, and it's kind of our introduction into probability. So the fundamental counting principle says that if 3 or more events occur in m, n, and p ways, then the number of ways all the events can occur is those letters multiplied together. So what that means, or what that would look like in an actual example, would be if you're at a restaurant and you have 8 different options for entrees, 2 different choices for salads, 12 different drinks, 6 different desserts. I don't know, how many different dinners could we pick where you have a salad, an entree, a drink, and a dessert? So what the fundamental counting principle tells us to do is take the number of choices we have for each of them and multiply them together. So we have our entrees, our salads, our drinks, and our desserts. We go ahead and list them all out and then multiply them up. In this case, when I do 8 times 2 times 12 times 6, we're going to get 1,152 different combinations that we could have for dinner. For number 2, we want to know how many 7-digit phone numbers are possible if the first digit cannot be 0 or 1. So what I like to do on these is I have 7 blanks we need to fill in. So it's a 7-digit phone number. So 1, 2, 3, 4, 5, 6, 7. And then we have the stipulation that the first digit cannot be 0 or 1. So we need to think, how many digits are there that we can choose from? Well, as far as digits are concerned, you go from 0 to 9 because it's just one number. So if I count all the way up from 0 to 9, there are 10 possible digits we can choose from. The first one cannot be 0 or 1, so I only have 8 digits to choose from for the first one. And then each of the remaining blanks, we have 10 possible digits we can choose from. Okay, because we're allowed to use any of them 0 through 10 on any of those 6 remaining spots. So again, we're going to multiply it all out, and we're going to end up with 8 million possible phone numbers. For number 3, we want to know how many 7-digit phone numbers are possible if the digits cannot be repeated and the first one cannot be 0 or 1. So again, first spot, we only have 8 we can choose from because it cannot be 0 or 1. And then from there, we have chosen a digit. So we only have 9 left over to choose from. For the next one, 2 of my digits are gone because they've been chosen and they cannot be repeated. So we're down to 8. And then we go to 7, 6, 5, 4. Again, to figure out all of the combinations, we go ahead and multiply those all out. It's going to give me to 483,840 different combinations. So that's the fundamental counting principle right there. When you have different events that are occurring, to figure out the different number of combinations, multiply them all together. Next thing we're going to look at is a factorial. For a factorial, what they're asking you to do is multiply the number by every number less than it until you get to 1. So for example, for A, they're asking you to go 6 times 5 times 4 times 3 times 2 times 1. So you could go ahead and do that whole thing by hand when you multiply it out. Or on the calculator, we can go ahead and hit 6 math. Actually, I'm going to go 6, and then we're going to go to catalog. And then if I hit up, we're going to go until we get to the exclamation point, which is going to be right here. So if I hit 6 exclamation point, it's going to go ahead and do the multiplication for me, where it starts off at 6 and multiplies its way down. For an answer, you should get 720. And then B, C, and D are asking you to do the same thing. For D, you're going to have the 10 multiplied all the way down so you get to 1 up top, 5 multiplied till you get all the way down to 1 down below. Same deal though, just plug it in the calculator. Okay, Next, we're looking at permutation. So permutation is going to be an ordering of n distinct objects. So with this, the deal is order matters. Okay, so if order matters, then we're going to follow these rules for permutation. So for number 5, we say 14 athletes are competing in the final round of the Olympic freestyle skiing. And on how many different ways can they finish the competition? So if you have 14 athletes, we're going to have 14 spots. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then we want to know how many different spots can they finish in. Well, since order matters and we can't repeat, we have 14 people that can finish in first. After that person has been chosen to finish in first, then we're going to work our way down. So we have 14 for first. There's 13 possibilities for second, and then we keep working our way down until we get all the way to 1. And then, same deal as the fundamental counting principle, you're going to multiply them all out. So if we go ahead and multiply it all out, we're going to end up with 8.7 times 10 to the 10 different combinations we can have. For 6, they're just weighted out first through fourth place. So you're going to go 4 blanks, 2, 3, 4. Write your numbers in and multiply them. When you do 14 times 13 times 12 times 11, you get 24,024 different combinations. All right, permutations for certain objects taken at a time. So here we have 5 different homework assignments. For example, 7. Well known, how many different ways can you complete them? So it's the same as the problems we've been doing. You got 5. Start off with and 4, 3, 2, 1. Multiply it out, gets me to 120. B is the new one. So it wants to know how many different ways can you choose 2 of the assignments to complete. So I have 5 of the assignments. I am picking 2. We care what order we finish in. So it's going to be a 5P2. On your calculator, we can actually type this in. So we are going to go to probability. So let me clear this out. We're going to go math, probability. We are going to NPR, and then we have 5 assignments, and from that we are picking 2. So we got 5P2. Hit enter. There are 20 different ways. Or you can do the same thing we've been doing. Have your 2 blanks. Go 5 times 4. Gives you it right there. All right, last thing I'm going to look at is distinguishable permutations. For a distinguishable permutation, I want to know in how many ways can these be listed out in different orders. So our formula for this is n factorial, which is our total. And then down below, each of these Q's represents repeats. Okay? So what that would look like is we have a dog that has 8 puppies. So my N is going to be 8. And then we have repeats. There's 3 males, so that would be my Q1. 5 females, that would be my Q2. That would be 5. And then from there, we are just plugging in. So my total factorial up top, and then my repeat factorials down below. And it's going to get me to 56. Okay. Down here, we have it with letters again. So I'm going to go ahead and just do Idaho. You look at Idaho, you have 1, 2, 3, 4, 5. So there's 5 total letters. I look at it, there's absolutely no repeats. So this one would just be a 5 factorial. And you would plug that in your calculator, figure out how many different ways those letters could be ordered.